Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 5.5, wherein we ask the essential question, how can you use a system of linear equations to solve an equation with variables on both sides? Well, we already know how to do that. We already know how to solve an equation with variables on both sides. So this is almost like a little add-on lesson in which we can use our skills with systems of equations to solve these types of equations. So for example, let's say we have an equation that looks like that. It has the variable on both sides. Now normally we would subtract from both sides and get all the variables onto one side. But what we can also do is write two separate equations. Since each side is equal to each other, we set them each equal to y. And I'm going to demonstrate that in just a second. So let that sink in just a second. Since both sides are equal to each other, I can write two equations setting them both equal to y. And then we solve it as a system. And so we can do it by graphing. That's really what we're trying to do here, is solve this type of equation by graphing. Okay, so let's take a look at an example here. And so here I have my equation that has the variable on both sides. Now normally, of course, to solve it without graphing, we would just add x to both sides and solve for x. But let's set both of these equal to y. Equals y. Since they're both equal to the same, then we can set them both equal to the same variable. And we're going to plug this into the graphing calculator. Voila, there's our old friend, the Desmos graphing calculator. And the first one was y equals negative x plus 1. So there's the graph for that guy. Let me go ahead and make this a little bit bigger so we can kind of see it a little bit easier. And the second one was 2x minus 5. There we go. And so here's our intersection here at 2, negative 1. But what we're really just interested in what? We're really just interested in the x value here. So in this case, x equals 2, and that's the answer to this first solution here. So x equals 2. Let's go ahead and take a look at a second example. And in this example, I'm going to bring this out a little bit bigger here. We've got absolute values. Now, we know how to do this. We know how to write two separate equations for this. We keep this one positive, and then we use the second one to do a positive and a negative case. So my two equations will be x plus 1 equals 2x minus 4. And then x plus 1 equals, if I multiply everything in here by a negative 1, negative 2x plus 4. Okay, so we've got essentially two systems here. Well, let me put one extra step in here so we can see the two systems. Y equals x plus 1 and y equals 2x minus 4. Then over here, y equals x plus 1 and y equals negative 2x plus 4. So we have two systems we have to solve for by graphing. So let's put these in the calculator, into the graphing calculator, and see what we get. Okay, so our first equation was y equals x plus 1. And our second, this is the first system, so y equals 2x minus 4. And here's our intersection up here at 5, 6. So in the first case, x equals 5. We're solving for x. So x equals 5. And then we'll do it again. But in this case, y equals negative 2x plus 4. And here's our point of intersection here at x equals 1. So x equals 5 and x equals 1. Remember, these are absolute value equations. We have two cases, two solutions here. So x equals Let me go back to this screen here. X equals 5 and X equals 1. Okay, so we have time. We'll do a little word problem here. I'll set it up. I'll let you finish solving it. Um, your family needs to rent a car for a week while on vacation. Company A charges $3.25 per mile plus a flat fee of $1.25 per week. So we know $3.25 per mile. That's our rate, and we're going to multiply that by, I'll use M to represent miles, plus $1.25. Company B charges $3 per mile plus a flat fee of $150 per week. After how many miles of travel are the costs the same? Okay, now remember these expressions. Let me do the expression for company B. $3 per mile plus $150 per week. Now these expressions represent dollars, right? So when it says the total costs are the same, that's what we're talking about. This is a cost in dollars. This is a cost in dollars. We want to know when are those the same, but we want to know when are the miles. When will the miles make the when will the equal miles result in equal costs? After how many miles of travel are the total costs the same for both companies? So there's our two expressions. I'll set them equal to each other. I'll let you go ahead and finish solving this on your own. You know how to do that using the Desmos graphing calculator now. But that's it for today. Like I said, a real quick little lesson on using graphing to solve equations with variables on both sides. Okay, thanks a lot, and I'll see you in class next time. Have a real good rest of your day. Bye-bye.